Hey everyone, I'm excited to be here speaking to all of you about building for the web. And what a great time to be talking about the web because, as you might have heard, earlier this year, we actually celebrated a huge anniversary. That's right, the web is now 10 years old. So Tim Berners-Lee shared his vision for the World Wide Web in March 1989, 10 years ago, in a paper titled Information Management, a Proposal, which his boss at the time heralded as vague but exciting. So he worked on this idea at CERN for the next couple of years, and then in 1993, we all got to play along with the release of the free Mosaic browser. And it's been a wild ride in the years since then. Of course, there's now tons of websites, new experiences and ideas, companies even built around the web, many of which I'm sure you've heard of, or maybe even some of you work for them. And the market couldn't love us more. So today I'd like to share some highlights of the new technologies that have made this possible, where we are now here in 1999, and a glimpse into the future of the web. But first, let's start with the basics. What is the web and how does it work? Well, a web page is just a normal file. It's just a rich text document written in HTML that contains clickable hyperlinks that refer to other web pages. And these references come in the form of a URL, which have two important parts. The first part is the website, and the second part is the web page. And with a little bit of magic, your browser finds the actual physical computer also connected to the internet for that website, and then asks it for the requested web page. And that computer runs a piece of software called a web server, which translates that requested web page to an actual file stored on its file system. It opens that file and sends it across the internet back to your browser using a protocol called HTTP, and this is amazing. But over the last few years, we've seen an evolution from serving static files or websites to dynamic programs or web applications. And this lets us make totally new kinds of experiences where the program's not being run on your computer, it's being run on a web server. And this evolution started with CGI. And that's both dead simple and, I think, super clever. CGI extends what a web server can do beyond just reading files by saying, if the requested file is in a certain directory, and we usually use CGI bin by convention, then that file is a program. And rather than just opening the file, it executes it with a handful of environmental variables set from the HTTP request, and then it sends that program standard out back to your browser over HTTP. And this is so cool because literally any program can now be a web application. It can be anything from a simple shell script all the way to a complex compiled C++ program. Of course, doing anything other than simple tasks is pretty annoying in a shell script, and C++ takes years to master and about as long to compile. Scripting languages like Perl are a great compromise and have become pretty popular for CGI, but Perl wasn't really designed with the web in mind. And here, PHP has really taken off. PHP was written a couple of years ago, back in 1995, but I think it really got interesting to our web community last year with the release of PHP 3. It's an open source programming language, and currently the best way to get started on the web. I say programming language because its creator said that he never really intended it to be a programming language, though it's definitely Turing complete, and it's become popular since it's really the first language built for the web. Its original goal was to process web forms and generate web pages, and it does both of those really well. And PHP feels revolutionary to me because it's blurred the line between files as web pages and programs as web applications. For instance, any typical HTML file is actually a valid PHP program. This one doesn't do anything interesting yet. It's more web page than web program at the moment, but we can insert a PHP tag, and now we're in application land. For example, we can access some state from a submitted form or a cookie. We can use that to query our database and then go right back into HTML, but with fresh data interleaved. And part of why I like PHP so much is that it's super easy to learn once you know HTML. You can incrementally include dynamic logic into existing HTML files, and it scales up to everything that you could do with Perl. And PHP is also free and open source. And it's part of what I've recently heard called the LAMP stack. LAMP stands for Linux, which is a free and open source operating system. Apache is a free and open source web server that supports CGI. MySQL is this new free and open source database. And then, of course, PHP. And these are all the tools that you need to build and serve web applications. And if you're not too familiar with open source software, this might not sound like a big deal, but it means that PHP and the rest of the LAMP stack is constantly improving from the web community's contributions, and anyone can use it without payment or licensing concerns. In fact, I predict that the recent excitement around the web will inspire a future generation to learn to program, and PHP and the LAMP stack will make it easy to do so. And all of this makes me wonder, what will the web look like in 10 or even 20 years from now? Before I get too far into all of this, I should probably introduce myself. My name is Byron, and I support web engineering at Robinhood, where we're democratizing access to our financial system. But I'm also one of the creators of GraphQL. I'm the author of Immutable.js and was an early contributor to React. And I'm particularly excited to be back with all of you here at React Europe because it was on this stage 4 years ago where I open sourced GraphQL. And I was back the next year to share how we experiment atop GraphQL. And then the year after that, I released Relay 1.0 from this very stage. And then last year, I shared a new kind of architecture, the IDEA architecture. And I'm back all the way to 1999. And so no, I'm not actually a time traveler, just occasionally detached from reality. I'm fully aware that the current year is 2019, which means that we actually recently celebrated the proposal for the web's 30th anniversary. And that means that our open source web developer community is well over 20 years old. And it's fun for me to look back on 1999 because that's when I first got involved with the web and taught myself to program by learning PHP and, building Pokemon fan sites with the LAMP stack. And in the decade after 1999, the web and really PHP exploded in popularity and relevance. The fact that it was free to use, easy to learn, and scalable led to a new post-bubble wave of companies built with LAMP, including some current giants, Wikipedia in 2001, WordPress in 2003, and Facebook in 2004. And PHP gets a lot of well-deserved criticism, but it's still relevant and probably way more popular than you think. Today, over 80% of websites are still powered by PHP. In fact, 30% of the web alone is specifically powered by WordPress. This stat kind of blows my mind. And I spent most of the last 10 of the web's 30-year history working at Facebook, where I saw the evolution of PHP, LAMP, and complex web apps. And what I think is most fascinating is that, to me, now 20 years later, the programming model and mental model of the web feels largely the same as it did back when these tools were first introduced. Of course, at the same time, we've tackled growing complexity, have built far richer experiences, grown our community 1,000-fold, and scaled to billions connected to the web. And I see a pattern behind this progress, a relationship between three kinds of advancements: better and more powerful abstractions, clear and more expressive syntax, and improved and refined mental models. In fact, these three influence each other in a sort of loop. We build better libraries and abstractions, which unlock new capabilities and better performance. We introduce new programming patterns, APIs, and ultimately new syntax into our languages to better express ourselves in terms of these abstractions. And that creates clarity, which allows us to improve our mental models, how we think about what we build. And so today I want to illustrate this process through a handful of stories and specific examples that I saw unfold at Facebook across three problems that we're all familiar with: rendering views, fetching data, and managing state. And I want to start with rendering views because it's so much of what we focus on as front-end engineers, and it was also PHP's killer feature. PHP really meshed well with the mental model of a web app as a mix of dynamic content interwoven with static content written in the lingua franca of the web, HTML. PHP kicked off this era of template languages, and more followed with embedded Ruby or ERB in 2004, mustache templates in 2009, and plenty more. And these made it easy to start with static content and then introduce dynamic values over time. But as you started to build anything complex, you quickly realized the need for Turing-complete logic, which means that these simple template languages either evolved into their own weird programming languages like PHP, or remained crippled and limited in use like mustache. And even templates with rich logic remain difficult or awkward to modularize or reuse without either relying on global variables or kind of losing most of the benefits of the template syntax. And then there's security. Templates often leave this totally up to you. Naive, simple-looking PHP code almost definitely suffers from critical SQL injection or cross-site scripting vulnerabilities. And these in particular were constant thorns in the side of early Facebook. So to resolve these issues, Facebook built a framework called UI Component. It's funny how this has now become kind of a general term. UI Component was heavily inspired by MVC frameworks at the time, and also on the browser's DOM API. So for example, a button might be called UI Button Component, which would be a subclass of UI Component, and to use this, you would just instantiate that class with new. And then you could configure it with a chain of method calls, add children UI components, add client-side behavior using a DOM-inspired API, and then call render to get the complete resulting HTML. And this solved all the problems with templates that we were facing. Now, building a UI was just code. No need to invent a new Turing-complete language. We have an API designed for modularity and reuse. And importantly, what we're building here is actually a tree of UI component instances rather than a stream of concatenated strings, which means that it's much easier to solve security issues in a systemic way. We can automatically escape content correctly based on where it occurs, and we can automatically include CSRF tokens in forms, even if you don't know what that means. Security issues solved. Reuse also led to a standard component library, which improved product design consistency. And this all sounds great, but a huge downside was that every time we refactored a bit of UI code from templates to UI components, we just couldn't shake the feeling that the new code was just worse. It was more verbose and harder to read, and there's definitely a reason why people prefer to write HTML over directly using the DOM APIs. So meanwhile, there was actually the Skunkworks project underway at Facebook to rewrite the site from scratch in an effort to achieve better performance and shed technical debt. And this, of course, didn't work at all, but it yielded a lot of really interesting technical things and ideas, one of which was an extension to PHP called XHP. So XHP introduced an XML-like syntax to PHP inspired by the ill-fated E4X JavaScript project. However, unlike E4X, XHP did not try to add any new runtime behavior for working with XML. Instead, XHP was just syntax sugar, that's it, atop working with plain old regular PHP classes, which made it much easier to describe a tree structure of class instances, and it was just as easy to read as HTML. And so this was a perfect match for UI components. The implementation details remained the same, but the syntax returned to what we loved about templates. Though now we had the added benefit of catching errors like a missing closing tag as a syntax error at development time, rather than a broken view or invalid HTML in production. So remember all those validator apps where you could like punch in your URL and check that your site's HTML was valid? I haven't used one of those in years. So the better abstraction of UI components with the better syntax of XHP further clarified our mental model. We built modular UI by defining them in terms of other modular UI, and that allowed us to replace an imperative mutable DOM-style API with a more declarative functional API. So you may or may not have heard of XHP before, but even if you haven't, you're probably hearing all this and thinking JSX. So you might not know this, but the initial versions of React did not include JSX. The author of React, Jordan Walk, had been working on the ideas behind React before he joined Facebook, and the idea to change the syntax of the language along with introducing a library of code was not something on his mind at the time. However, as other front-end engineers at Facebook first started to see React, they immediately responded with skepticism. Their mental models had already been shifted by XHP, and it wasn't until introducing JSX that React started to be adopted within Facebook. So imagine our surprise when we open-sourced React in 2013. People hated it. Specifically, they hated JSX. Facebook engineers had already adjusted their way of thinking about developing UIs thanks to XHP, but it would take another couple of years for the rest of the web community to come around to JSX. And so I think this refinement of abstraction, syntax, and mental model continues with post-React UI libraries. Vue.js and Svelte take it full circle back to this original compelling idea that any bit of HTML is a valid component, a valid program. And it kind of feels familiar in this way, like the simple PHP code from 1999, where any HTML was also valid PHP. So looking back, part of what I think made LAMP so empowering was just how easy it was to set up and use a MySQL database and just start creating data-driven views. Early simple web apps had easy-to-follow imperative code. Query your database with SQL, save the result to a variable, and render a template with that variable. And this worked great in an era where a web app was just a single instance of PHP and MySQL installed on one machine or VM. And it was simple, it worked well, and it was pretty easy to maintain. But it couldn't really scale past thousands of users or to more complex data-rich applications or to large teams of developers. Of course, Facebook needed to do all of these things. So a quick side story, the earliest versions of Facebook were actually created by just scaling a single different physical computer with a fresh MySQL database for each new school that it launched at. That strategy didn't last very long, especially as Facebook started to include more complex data-driven features like Newsfeed. And Newsfeed made data fetching challenging because there wasn't really a single performance SQL query that you could write that would get everything needed for a feed of kind of heterogeneous content. And even if there were, Facebook was using memcache to improve performance, and that required cacheable key-value pairs. So building Newsfeed with memcache led to the dreaded N+1 problem. Attempting to load multiple values from a list of keys, each independently leading to many simultaneous blocking queries per page load, which could be very, very slow. So Facebook solved this by building a library called Preparable. A preparable was really just a simple state machine. It was a class instance with a method called prepare, and it contained a switch statement. And it was passed a number that told it what state that it was in. So each step either enqueued some data to be fetched and returned true, which meant that it should advance to the next state once that data was available, or it fetched some additional data and returned false to indicate that it was at the last step. So a preparer collected a list of preparables, each of which was focused on a very specific need, like one per story in a news feed or a notification or whatever else happened to be on the page, and the preparer called prepare on each preparable. When all preparables were stuck waiting for data, then a single batched request could be sent to memcache for everything requested up until that point. And then it could return and advance the state of each preparable, and then just continue like this in a loop until all the preparables were completed. This solved the N+1 problem since it resulted in the fewest batched memcache requests, regardless of how complex the page was, while allowing each element of the page to have independent logic that was unaware of all of this happening. So this allowed Facebook to grow far more complex and data-rich, while maintaining both great performance and a modular, maintainable codebase. And preparables worked well, but as you might suspect, they became a frequent source of bugs. It was easy to accidentally forget to return or break a switch statement, and maybe forget a number if you did some refactoring. But we stuck with it and did our best to catch these issues during code review or maybe write linters. And I thought this was super clever until I learned about generator functions. So generators are functions that, rather than completely running from top to bottom before returning, they let you yield control back as many times as you want, and then the caller of that function is responsible for asking it to carry on by calling a next method. And generators have been around for a long time in some form since the 70s, but were first popularized by Python in 2001, and then introduced into JavaScript by Mozilla in 2006 as a proposed addition to ES4. And then ES4 was canceled. And then Harmony was started as an effort to bring back some ES4 features, and that took forever. And that effort was later renamed ES6, and then ES6 also took forever. Finally launched in 2015, so generator functions actually took about 10 years from Mozilla's first version to shipping in a first browser. So unsurprisingly, JavaScript developers at the time were pretty apathetic and had no confidence that Harmony would ever ship in browsers, and started to take it upon themselves to build tools that allowed them to extend the language before there was actually official browser support. You probably all use or at least heard of one of these, Babel. That was originally called 6-to-5 because it translated ES6 to ES5. But even before that project, one of these translators, one of the first ones, was called Regenerator. So Regenerator specifically transformed generator functions into JavaScript that any browser could run. And this blew my mind. I thought generators were such a new runtime concept that this shouldn't be possible. So I had to learn how this worked. So I wrote a simple generator function, put it through Regenerator, and what came out the other side? A preparable. I learned that a generator function was actually just clever syntax for describing a state machine, and they could be translated into exactly the same kind of switch statements that we were manually writing for preparables. And later enhancements to preparable at Facebook included nested child preparables, handling errors, and adding loops and other complex state transitions. And these all align exactly with generator function syntax like yield star, try catch, and typical control flow like for and while loops. And generator functions gave us syntax for these state machines, but they're kind of meant for producing multiple values over time, and preparables are really about complex asynchronous behavior that resulted in a single final state. And that much better aligned to a different ES6 feature, promises. So you could kind of think preparables like a chain of then callbacks in JavaScript promises. So in 2012, we spotted an even better fit. C# had introduced async functions, an unholy union between the state machine modeling syntax of generator functions with the asynchronous abstraction of promises, or C# called them tasks. So light bulbs went off, and Facebook again extended the PHP syntax to include async and await, and undertook an effort to replace preparables with easier to understand and far less error-prone async functions. This further clarified our mental models, and later async functions and XHP components were merged to create Gen XHP, where data fetching and component rendering could become co-located. That led to much better encapsulation of complex data-driven componentry, and this final evolution was happening right as we were starting work on GraphQL. And I think you can see the influence of async functions and preparables on the syntax and execution behavior of GraphQL queries. And in fact, we later realized just how important preparables were to GraphQL that we were inspired to create an open source data loader to help solve the same N+1 problem for JavaScript. And the resulting mental model from using Gen XHP inspired front-end engineers at Facebook to build Relay, which borrowed the idea of co-locating data needs with UI components from the server to the client. So this evolution of better abstractions, clearer syntax, and refined mental models led us to these ideas like Gen XHP and Relay that feel somewhat familiar, like the simple PHP code from 1999 where you could just write imperative code in one file where you asked for what you needed and then rendered what you wanted. Early web apps actually used very little JavaScript. Really, the first 15 or so years of the web featured applications with an enviously simple model for managing state. Load a page, click a thing, which loads another page, or maybe you submit a form, which again loads another page. And the programming model for interacting with state over time in this pattern was also simple. Read a form value, read a cookie, update some server-side state, write a cookie, write some HTML. This, really, is the OG one-way data flow for UIs. Of course, this means that every state transition is a full page load, and in 1999, that happened over a dial-up connection, which was usually painfully slow. And it also doesn't allow for rich client-side or event-driven apps like chat. Facebook Chat was the predecessor of Facebook Messenger and was really the first client-side JavaScript-heavy experience on Facebook. It was built in 2008, and it followed the well-established MVC pattern at the time, and this was 2 years before Backbone.js was released. However, for years, the same bug kept popping up over and over again, the zombie notification. Something on Facebook would light up like you had a message, and excited you go to click on it, only to find no new message for you. And this was actually the first project that Adam Wolf, my longtime manager, worked on at the time when he first joined Facebook. He's now actually VP of Engineering at Robinhood with me, so if you're in the Bay Area, you should come join us. We're a fun crew. He first wanted to better understand exactly what was causing the problem, but at the time, chat had no automated tests. And it was actually pretty difficult to test because it relied on subscribing to all these various complex event sources that came from many different sources. And that led us to build a new JavaScript test framework with mocking as a first-class concept, Jest. So we were actually using Jest at Facebook for 4 years before we open-sourced it. And so with tests in place to catch regressions, we now better understood the problem. Events resulted from updates to the chat UI, and those could come from server-pushed events, metadata from a page transition, or just people directly interacting with the chat UI. And also, chat appeared in at least 3 different places: in the messages view, in the chat bar on the bottom, and the notification icon in the top corner. And each of these different views had their own logic, their own code bases, and their own way of handling events and keeping themselves up to date. So this was just impossible to keep track of in your head, and it led to lots of inconsistencies just because of, easy-to-miss edge cases in the code. So the solution was to rewrite chat with a new architecture. They took the mental model of simple server-side state, but implemented it all in client-side JavaScript. So any event which could alter state changed from an event emitter to instead be represented as an action. This is my new favorite meme, by the way. An action is just a declarative description of what should change, and this declarative action is then dispatched to a store, much like you would dispatch a POST request to a simple stateful web server. We called this architecture Flux. Of course, for this simple web server style approach to be complete, the result of dispatching an action should be similar to what happens in response to a web request. The entire page should be replaced with the response, which includes the results of that change. That would be very different from how we were building client-side UIs at the time. If you looked at the callback for the new message event, it would be directly constructing a new DOM node and calling append child on the chat window. And there's a reason that we were avoiding this. Changing from this to replacing the entire view wouldn't necessarily be any better, since it could be slow, it might flicker the UI, and you could lose things like your scroll position or whatever you happen to be typing at the moment, which was of particular importance for chat. And these, of course, were some of the motivating reasons for building React. So Flux and React together provided a much better abstraction for managing state, which allowed us to bring the one-way data flow of simple PHP apps of the 90s to the dynamic JavaScript clients of today. Of course, now few of us use Flux like it was presented 5 years ago. We've since then again continued through this loop of better abstractions, clearer APIs and syntax, and more refined mental models. It led us to Redux, using connect decorators on our React components, and thinking of state like reducer functions. React has also continued through this loop, adopting class syntax, further clarifying the mental model of component lifecycle, improving the abstraction with React Fiber, and further simplifying syntax with functional components and React hooks. So React functional components with hooks, they feel familiar to me, like that simple PHP code from 1999 where you just wrote a function that declared your state and then rendered a complete view with templates. So I think LAMP has become so popular in large part because PHP provided a compelling mental model with expressive syntax for building web apps. And 20 years later, it feels like we've kind of found ourselves back to where we started. And that's thanks to the steady march forward of better, more powerful abstractions, clearer and more expressive syntax, and an improved and refined mental models. And this has helped us build richer, faster, more complex experiences, grow our community to millions, and connect billions of people to the web. And now with the benefit of hindsight, it's not all that surprising to me that Facebook has been responsible for pursuing a lot of these ideas. It was originally built like people who, like me, learned programming by building things for the web back in 1999 with the LAMP stack. As Facebook grew in product complexity, popularity, and team size, it encountered all of these challenges and became frustrated with the existing solutions and drew inspiration from the simplicity of the early web. And that led to better view rendering with XHP, React, and JSX, better data fetching with preparable style batching, async functions, and GraphQL, and better state management with Flux, Redux, and now React hooks. And I don't think we're anywhere close to done either. There are still plenty of problems to improve upon which could benefit from this progression of better abstractions, syntax, and mental models, maybe again inspired by ideas from decades ago. All of which makes me wonder, what will the web look like in 10 or 20 years from now? Thanks.